Whizlabs SCJP 6 training demo. I'm Shantanu. I'm Whizlabs SCJP 6 instructor, and I will be taking the next month's training in November, for which this demo is all about. So before we begin our session, a little bit about my credentials. So I did my SCJP certification in December 2009, as you can see from this slide, and I did my SCWCD certification as well just last year in February. I have a training experience of well over 3 years with Whizlabs. Now a bit about OCJP 6 exam. OCJP 6 exam is of 150 minutes duration. The total number of questions is 60 and passing score is 61%. Now the book that we recommend for this OCJP 6 exam is SCJP 6 Study Guide by Kathy Sierra and Bert Bates. This is an excellent book to study for this exam, and this is the book that we also follow in our 4 days of training. So when you join this training, you will be actually needing to have this book. And based on this book, I have actually divided the complete exam syllabus into these 7 sections. Okay, you can see these 7 sections, and this slide will actually tell you which section is covered on which day of our training. Okay, so you can see all the 7 sections are covered based on a logical flow on a particular day on the training. All right, so that was the small introduction part. Before I actually go on to the technical discussion that I wanted to have today, if anybody has any question till now, please do let me know. Please try to keep this session as interactive as possible. Anytime you have any questions, feel free to ask it through the questions panel, or you can raise your hand and I can unmute you. Any questions anybody is having so far? Any doubts, anything's not clear? Okay, so I will take that everything is all clear. Okay, so I will proceed ahead. Okay, so let's start with the topic that I actually wanted to discuss today, and let's start with a small size sort of I would say. So let's say we have a class called shape. By the way, guys, I hope this Eclipse screen is clear to all of you, and you're able to see this whatever code I'm going to type in here clearly. Few yes in the questions panel will be great, confirming that. Okay, great. I can see a couple of yeses. That's great. All right, great. So okay, let's say we have this class called shape, okay, and what I define inside it is a method, let's say called public in get total area. Okay, now obviously shape is a very general term, right? When I say shape, it can actually mean a lot of things, right? It can mean a rectangle, it can mean a circle, it can mean a triangle, it can mean basically any kind of shape at all, right? Any kind of shape that you can think of, this class shape can actually represent that. Now, so until I actually know about that shape, or I have more details about that, I will not be able to define a concrete implementation of this get total area here method here, right? Okay, so let's say what I do is something like this. I just say return 0 because I cannot do anything in this get total area implementation inside this shape class. Okay, and I define, let's say, another class called rectangle, okay, which extends from shape. And in this class rectangle, obviously rectangle has a width and a length. So let me define those instance variables here. Let me just quickly generate a constructor for this. And now obviously in the rectangle class, I can actually define the area get total area method, and it will be basically just length into breadth, right? Guys, just give me a minute. Let me resize the screens a little bit, and let me just create a main method here as well, just for some testings. Okay. Now, can anybody point to me that if he or she can improve this design a little? Okay. Can you see something wrong in this design, or which is actually not correct, and you should actually correct that thing? Anybody? Anyone? Okay. I can see one comment from Claudio. So Claudio is basically saying that you should make the get total area method from the shape abstract, right? And Brent, I think you also mean the same thing. You are saying that shape shouldn't be concrete. So probably shape shouldn't be concrete because it can contain certain methods which cannot be defined inside it, right? So it should be also made as abstract. So absolutely correct. What we should actually do is make this get total area as abstract. The reason why we should make it abstract and not leave it like this, because this is a big design flaw. Because let's say if the developer who developed this rectangle class forgets to, if yeah, right, that can happen, right? And you can, compiler is not giving you any issues at all. You can see when you forget to override get total area, compiler is not giving you any issues at all. And now let's say your client, what he or she does is that he creates a rectangle object, and they call get total area here. So what is the answer they are going to get here? Oh, sorry, rectangle needs to be initialized with some values. So let's say 5 and 4. What is this going to print out? 0, right? This will print out 0 because right now you have not overridden the get total area method, and hence you are inheriting this implementation which is returning 0, right? So you get 0 here, your client will say, okay, I'm getting 0 for rectangle, and now you will file a bug, and then this thing will be fixed, right? So it's a long cycle, right? If this could have been detected at the compile time, then you would not have faced so many, you can say, so you would not have faced so many cycles in fixing this particular issue, right? So what ideally you should do is, when you know that, okay, there is a method for which I cannot define an implementation at current time, what you should do is you should just make that method as an abstract method rather than providing some default implementation which doesn't make any sense, right? So what you should do is just make this as abstract. Abstract methods in Java are those methods which do not have any body. Okay? Abstract methods are those methods which do not have any body, and a class which is having even one abstract method, it has to be made as abstract. Okay? So what I need to do now is I need to actually make this class shape also abstract. As soon as I do that, you can see class shape is compiling now, but rectangle is not compiling. Rectangle is not compiling because rectangle is a non-abstract class, and any non-abstract class which is inheriting an abstract method, it must provide an implementation of it. Okay, so you can see now we actually caught this issue of get total area returning 0 in the rectangle class itself, right? Now the developer of rectangle class will never forget to define a get total area, and as soon as you do this and now you run this code, you get the correct answer, which is 20 for this particular case. Okay, any questions so far, anyone? Eugene's question is, wouldn't a method without a body be abstract by default? Eugene, so if in Java, if you're defining a method which doesn't have any body, you have to actually write abstract before it. Okay, this is actually done just so that the compiler is sure that the intention of not providing a body is actually of developer, right? And it has not done by mistake. Right. So for example, if it was the case that you don't need to write abstract keyword, then there will be many issues in which people will just simply forget to define a body of a method rather than intentionally not providing that body, right? So because of that, this abstract keyword is needed if you want to have a method which doesn't have any body, just to make sure that this is indeed what you want, right? Just a kind of double check, you can say. Okay, Gaurav's question is, can we overload abstract methods? Gaurav, yes, definitely you can definitely overload abstract method. You can just define another abstract method here, which is again get total area. The name would be get total area, and which will be taking an argument. Okay, you can definitely do that. That's not an issue. Ashish question is, what is the use of abstract class? Ashish, abstract class, as you can see here, defines a very general term, right? So for example, you can have classes like rectangle, circle, etc. And they all should have a get total area method, and they probably will have some more common APIs that should be available in all the classes, right? So rather than creating those classes independently, what you can actually do is create a general class which actually represents all those things, right? And then just create those specific classes one by one, extending from that parent class. So here you can see shape is the common class, and specific shape is represented by these concrete classes like rectangle, circle, etc. No, okay, I will actually give you a better example that what is basically the use of abstract class and why actually do you need to do that. Let's say instead of creating abstract classes, why don't you deal with just specific classes, right? Let's say class rectangle, class circle, etc. Let me tell you the reason why you would actually not want to do that. Okay, so let's say you have a few shape related classes that you have defined, and they are actually not they are actually not, let's say, extending from shape. They are just concrete classes. Okay, so let's say you have class called rectangle. Okay, it is having some method and specifically that get area method. Then you have a class called circle. Okay, again it has that get area method. And finally you have another thing called, let's say, class triangle. Okay, now let's say your client comes, you have a client who actually want to use all of your classes, and he or she specifically says that the only thing that he is concerned about these classes is their area. Right, so whenever you have a rectangle, whenever you have a circle, whenever you have a triangle, he is only interested in their area and nothing else. Okay, he is not interested in any specific property of rectangle like its length or width. He is not interested in any specific property of a circle like its radius, right? And he's not interested in any specific property of triangle like the length of all its three sides and whether the triangle is equilateral or isosceles, etc. All he or she is interested is what is the area of that particular shape. Now if you do not have any parent class from which all of these will be extending, what your client will need to do? Your client will actually need to define methods like this: public void process rectangle, correct, and in which he or she will just get the area by calling the get area method and do whatever he or she wants to do with that, right? Similarly, he will actually create another method here for this time, let's say for circle. Obviously this is a redundant code, a lot of same in these two codes, because all he or she is interested is in getting the area and doing something with it, right? So for example, what he would be probably doing is something like this: area equal to rectangle dot get area, And for now, let's say he is just printing it out, okay? And same thing he or she is doing for circle. Now there are two issues with this code that you are seeing here. First issue is that you have to define a process method for each type of these classes, right? Class rectangle, class circle, class triangle, whatever classes he wants to process, he has to provide a method for each one of them. Second problem is, let's say tomorrow you introduce a new kind of shape. Okay, you create a class for a new shape, right? Then the client will actually need to create a new process method. That is, the client will need to change his or her code to actually process that particular shape, right? Which is actually not a good design. So what you should actually do is, instead of exposing these classes to client, just expose him or her just one class called shape. Just expose to him just one class called shape. Make all these classes, circle, triangle, rectangle, etc., extend from shape. Okay, and what your client will need to do is, he or she will now need to just provide one method called process shape, which will be able to handle all kind of shapes. Okay, so for example, you will just say shape.getArea, and you don't need this method now. This is it. You can see it has provided two benefits here. The client has just one method to process any kind of shape, and he or she is not affected by any new shape that is introduced in your system. So if you, let's say, introduce any new shape tomorrow, right? Obviously it should extend from shape. The client code is already ready to process that. Okay, client will not need to modify his or her code to handle that particular new shape that you have created. Is that clear? Any questions anybody is having so far? Eugene, I will just come to your question regarding when to use an interface and when to use an abstract class. Okay, I don't see any question anymore, so let me come to Eugene's question. So the what exactly is an interface? Interface is basically just like an abstract class which has all of its methods as abstract. Okay, an interface is like an abstract class in which all of its method as abstract. So if you have a scenario in which you have an abstract class and you are making all of its methods as abstract, then you should ideally replace that abstract class with an interface. So Eugene, as you suggested, definitely we should actually have the shape as an interface, not a class, because it has just one method inside it which is abstract. Okay. So if you have a class, let's say, in which there can be few abstract methods and few methods which do not need to be abstract, right? So that their functionality will be common in all the classes that will be extending from it. Then you need to actually go for abstract class. So you can basically use this as a basis to decide whether to go for an interface or whether to go for an abstract class. If all the methods in an abstract class are actually abstract, then just convert it to an interface. Otherwise, you obviously have to keep it as abstract class because interface cannot contain any methods which will have an implementation. Any questions anyone is having here? Okay. I'm sorry. I just your question is basically, can we make a main method as an abstract method? And I see any reason why will you actually want to make main method as abstract. Actually, you will not be able to make the main method as abstract, right? You would need to have a class which is actually inheriting from that particular class, and then you will need to override the main method in that. So yeah, making main method as abstract actually doesn't make any sense. So you will not be actually able to do that. Okay. Now, next thing is, when should you actually provide an implementation for an abstract method, right? So for example, here it is quite clear that this class rectangle must provide an implementation of this getTotalArea method, which it is inheriting because it is abstract. Okay. Now, this can actually become a little tricky if you have an inheritance chain which is extending, let's say, more than 3 or 4 classes. So if in an inheritance chain, let's say you have 3 or 4 classes, then you have to follow a systematic process to decide whether a particular abstract method needs to be implemented or overridden in a specific class. Okay, let me give you some reasons for that. Let me just clear this up. Let's say we have a class called A. Oh, Eugene's question is, having main method in an abstract class is not a good idea. Do you agree? Eugene, actually you can do that. Having main method in an abstract class, you can actually do that. I don't see any problem with it. The reason is that you can actually invoke static methods on abstract class, right? Static methods can be called directly on the class. They do not require any particular object of that class, and hence having main method, which is obviously the static method, inside an abstract class is definitely fine. It doesn't have any issue at all. You can do that. Okay. Here, in fact, I did that here. You can see that the class shape is there, and I provided a main method here. Definitely, you can do that. It will again depend upon what kind of problem you are actually trying to solve. But definitely not a design flaw according to me. You can actually do that. That it should not be a problem. Okay, so let's see here that we have a method called public abstract void m1. Okay, and let's say we have another class called B, which is extending from A, and okay, class A needs to be abstract first of all. Okay, and I make class B also as, okay, let's not make it abstract. Will this code compile as it is? Or do I need to make any change here? This won't compile, right? Because you have this class B which is extending from A, and A has an abstract method, and this class B must provide an implementation of that M1 method, right? Now let's say what I do is I make this class B as abstract. Now do you think this code will compile? Now this will compile, right? Because class B is abstract class, and abstract class do not need to provide any implementation of any abstract method that they might be inheriting. Now let's say I have another class called C, which is extending from B. Will this class C compile as it is? The class C will not compile, right? Because it is extending from B and B is extending from A, and this abstract void M1 method is implementation is not present. So this method's implementation needs to be provided. So what I should do to make this compile is following. Okay, some implementation here. Now let's say I move this method from here to class B. Will this code still compile, or will it give you compilation issues? Alright, so guys, this will actually compile. Let me tell you how can you actually easily determine whether a method needs to be provided or implemented in a class. What are the steps that you actually need to do to determine that? So it is very simple. All you need to do is first of all determine what is the complete inheritance chain. So for example, in this case, we have A followed by B followed by C. Okay. Now, let's say you want to determine what are the methods that this class C must implement, right? In order to determine whether class C will compile or not, you have to determine what are the methods that this class C must implement, correct? So what you will do is you will start from the parent class, class A. You will look at each and every method defined in class A, right? You will pick each and every method defined in class A one by one. So for example, there is this M1 method, right? You will see that, okay, this is abstract in class A. Now you will go to the next class, which is extending from class A, which is class B. Here you will see what is the status of M1, whether it is still abstract or whether it has been made as non-abstract. So you will see, okay, here it has been made as a non-abstract method. And hence, by the time you reach class C in the inheritance chain, this method is no longer abstract. Okay? So you do not need to provide an implementation of it in class C. Okay, let me actually introduce one more thing here. So let's say we have another method here called public void M2, okay, which please notice is a non-abstract method. And what I do is in class B, I do something like this. Will this code compile now, or will it give any issues? Alright, so I think all of you have answered correctly. This M2 method, you can see by the time you reach class C, it is an abstract method. Even though originally it was not an abstract method in class A, but by the time you reach class C, it has been made as an abstract method, right? And that is why an implementation of it needs to be provided in class C. Otherwise, it will not compile. So whenever you want to determine whether a method should be implemented in a class or not, all you need to do is following. Just start from the topmost class, right? Wherever that method is first defined. And from there, just go through each and every class and check what is the status of that method, whether it is abstract or non-abstract. And by the time you reach that particular class, for example, like class C here, just see what is the status, whether it is abstract or non-abstract. Okay, let me just show a review question here, which will just make sure that we have understood whatever we have discussed so far. All right, so first question is, please have a look at this class A and class B here. Right, let me know if you think these two classes will compile. Forget about class C for now. Forget about class C, just concentrate on class A and class B. There is actually one issue in one of these classes, right, or maybe in both the classes. Let me know what is that issue, if you can find it. Ashish, class B doesn't need to implement M1 because class B is abstract, right? You can see class B is abstract, so it doesn't need to actually implement M1 method, which is abstract in class A. You can just see 3-4 answers. Okay, and I can see now few correct answers. So, okay, as I think Brant and Eugene has written, you can see, please notice this definition of M3 that is defined here. Okay, you can see that even though M3 has been declared as abstract, it has been provided with a body here, right? Which is wrong. Abstract class in Java can never have a body associated with them. This is a common thing that you can actually be asked in the SCJP exam. It's probably a little difficult to notice these braces here, right? Because they have been written in just a small space here, and sometimes you just overlook this thing, right? So the main purpose of this class A and this particular issue here was just to make sure that in the exam, if we get this kind of thing, you do not overlook it, right? And you can easily identify this thing in the exam. So whenever you see any abstract method in any exams question, just make sure that it doesn't have any body. If it has a body, you already have an answer straight away, compilation error at that particular line. Okay. So is this clear to everyone that this M3 is not correct, and in order to make this compile, what we need to do is this, right? Okay, next question. What are the methods that class C must implement in order to compile? You can see class C, what are the methods that it needs to implement in order to compile? Okay, I can see few answers. Okay, so guys, let's look at each and every method one by one. Okay, method M1. So again, as I said, if you start from the parent class, you will see method M1 is abstract in class A, and it has not been touched at all in class B. You do not see any definition of M1 at all, right? So it is still abstract by the time you reach class C. So M1 is definitely one of the method that you need to implement. Okay? M1 is definitely one of the method that you need to implement. M2, M2 is private in class A, right? And anyways, it is implemented as well. So you do not need to do anything with M2 in class C. It is in fact not inherited at all. Private methods are not inherited in the child class. Okay. So M2, you don't need to do anything about it. M3, you can see M3 is abstract in class A. But when you reach class B, you can see that you already have provided an implementation of it. So you do not need to implement it in class C. You can do it if you want, but you don't need to do it to make this code compile. Okay, so M3 doesn't need to be implemented. M4, M4 is non-abstract in class A, but it has been made as abstract in class B. So M4 needs to be implemented in class C, because by the time you reach class C in the inheritance chain, M4 is abstract. And lastly, the M5 method is fully implemented in class B. You do not need to provide any implementation of it in class C. So only two methods, M1 and M4. Any questions anybody is having here? Is this clear? This question clear to everyone? Okay, great. Um, Let me come to one related topic. Do you think abstract classes can have constructors? Can you define constructor in an abstract class? Anyone thinks that abstract class cannot have constructors? Because you obviously know that you cannot create objects of abstract classes, right? You are not allowed to create objects of abstract classes. Any reasons why? Why can't you create an object of, let's say, this shape class? Yes, as Eugene has written, absolutely correct. It can happen that, for example, this an abstract class has an abstract method, right? It is not necessary that an abstract class must have an abstract method. In most cases will be the scenario, right? So if you are allowed to create an object of abstract class, it can happen that somebody can try to call an abstract method on it. Then what will JVM do in that case? Because abstract classes do not have, abstract methods do not have any implementation, and if you try to call an abstract method, right, then there is nothing JVM can do about it, right? It will actually crash at that point of time because there will be no implementation associated with that method, and hence that is the reason you are not allowed to create objects of abstract classes. Okay. Now I can see a couple of questions which I missed. One question is from Gaurav. Gaurav is asking, it means if in hierarchy, if any class is made as abstract, it must have an implementation in next concrete class. Gaurav, yes, you are, I would say, partially correct. So if in a hierarchy you have a class which is having an abstract method, right, and obviously the class will be abstract as well, then it is not necessary that the next concrete class will need to provide an implementation of that abstract method. The reason is, if that concrete class is immediately after that abstract class which you're talking about, then yes, concrete class will need to provide an implementation of that method. But if, let's say, there is an abstract class between the original abstract class and your concrete class, then the middle abstract class can actually provide an implementation of that abstract method, right? In which case, your concrete class will not need to provide an implementation of that method, right? I'm sorry, I just mentioned it in that manner because I was not clear whether you meant that the concrete class is immediately after abstract class, or it is just the next concrete class and it can lie any levels after that abstract class. Okay. Ashish has two questions. Shape doesn't have constructor. No, Ashish, shape does have a constructor. In fact, every class in Java does have a constructor, even if you do not define a constructor explicitly. So for example, whenever you do not define a constructor explicitly in a class, you do get a constructor which is the no argument constructor. So in this class shape, you will actually get this constructor for free. Okay, public shape, this constructor is available freely for you, but the thing is that you cannot call it explicitly. So what you cannot do is you cannot use new operator and then shape after it to create a shape object. You cannot do that. Okay. And your question regarding reference variable, yes, you can have the reference variable for class shape, and in fact, that is a very common scenario to have a reference variable of the abstract class and the actual object of one of the child classes of it. So for example here, you can actually say something like shape rect equal to new rectangle and then rectangle dot get total area. Okay, something similar to what we discussed regarding that client example, right, in which I created few shapes, circle, rectangle, etc., right, and then I discussed about that get area method and how people will actually need to um, can actually introduce a shape class as abstract and then make other classes extend from it, so that your client just have a one method called process shape, right, rather than process rectangle, process triangle, etc. Okay, just one small topic to finish with today. Okay, so let's say we have this class shape defined here, and in this shapes constructor, what I do is I say shape, and in this rectangles constructor, what I do is I say system.out rectangle, okay, and I say whatever shape rect equal to new rectangle 5,4. This is also good enough. What is the output that you are going to see? Forget about this last system.out. I have commented that out, right? So don't need to worry about it. Just tell me what will be the output if you say shape rect equal to new rectangle 5,4. Okay. So guys, answer here is as Eugene has written, answer will be shape followed by rect. You can see there is system.out written in the rectangle constructor, which should definitely be called whenever you call this rectangle constructor. Similarly, there is a system.out defined in the shape constructor as well. Okay, but you can see you do not see any call to shape constructor being made, right, made here, right? So what is going on? How is shape getting printed? So reason that the shape is getting printed here is following. Whenever you define a constructor in Java, the rule is that the first line of that constructor should always be a call to the parent class constructor, always. Okay. In case you do not do it yourself, for example, like here, I'm not doing that, right? I'm certainly not making the first line in the constructor of rectangle as the call to the shape constructor, right? It is a system.out, as you can see, right? In that case, what is going to happen? In that case, compiler will try to insert that call for you in the bytecode. So when the compiler compiles this, it will see that, okay, you're not having the first line as a call to the parent constructor. So it will try to insert a call to the no argument constructor of your parent class. Note that it will only try to insert a call to the no argument constructor and not any other constructor, even if other constructors are available as well. Okay, now you can do this explicitly yourself by saying super, or else anyways you are going to get that as the first line in the bytecode, because compiler will do this for you. But this has one very important implication. The implication is that what if your parent class doesn't have any no argument constructor? It can happen, right? So for example, right now you can see shape has a no argument constructor, but let's say I make the shape constructor take a parameter in val. Right now it is not compiling. It will not compile because as soon as you provide even one constructor in your class, you do not get that default no argument constructor. That constructor is taken away. You do not get that no argument constructor. Okay, so when the compiler compiles your class and whenever it sees that it doesn't have any explicit constructor, then only compiler will insert that no argument constructor. Otherwise, no argument constructor will not be inserted, and hence you can see this code is not compiling. The reason is that compiler is trying to insert a super call in the rectangle, right? And it is not able to do that because shape class doesn't have a no argument constructor. So what you should do to fix this? Anything you can do to fix this? Okay, so what you can actually do to fix this is that just make a call to the superclass constructor yourself. In fact, what the compiler error message will be is actually saying that implicit super constructor shape is undefined, must explicitly invoke another constructor. So what you need to do here is that you need to say super and just provide some parameter here. Okay. Now compiler is happy because it sees that, okay, already there is a call to the parent class constructor in the first line and I do not need to do it, right? So all is well. Okay, let me test this thing with just one more question, and that will be the last question for today. This one question, it will just test you guys on this. So you can see three classes, class A, class B, class C. Please tell me what will be the output. You can see a few options. Let me know which is the correct option according to you. Any answers here? You just need to pick one of these options, A, B, C, D, E, F, or G. Okay, I can see a lot of A's, few C's, and I think one G as well. So Brent, will you tell me what is the reason you think this will give you compilation error? You can just type that, or if you want to speak up, I can unmute you as well. Your call. So you can just type it in the questions panel here that what is the compilation issue you see here. Okay, so absolutely correct. As Brent has written, please note that class B doesn't have a no argument constructor, right? It has just one constructor which is taking int as the parameter, and we just discussed that whenever your parent class doesn't have a no argument constructor, in the child class you explicitly need to invoke the parent class constructor, right? So here you can see class C is extending from class B. Class C doesn't have its first line as a call to the parent class constructor. So what compiler will try to do? Compiler will try to insert super here, which will fail because parent class B doesn't have this constructor, and hence you will need to do this explicitly, super 6, right, or any int value here to make this compile. Otherwise it will not compile, complaining that class B doesn't have a no argument constructor. Okay, same thing, just what we discussed in the Eclipse screen a few minutes earlier. Okay, is this clear? Anybody having any questions here? Raj, I think you can take over in the meanwhile.
Shantanu, yeah, I can take the action now. So guys, I hope you are able to get your query solved. So Shantanu, if you're still able to see any question asked by any participant, you can reply it, and then I'll take the access back from you.
Raj, I'm not seeing any questions right now, so you can take over. Meanwhile, if anybody has any questions, I'm anyways checking questions panel, so I will respond as soon as I see one.
Okay, great.